Testing code by running it is fine, but particularly when you get an error, that really isn't necessarily enough. You really need to understand what's going on to figure out where your error came. Let me just mention as an aside here, some people start making random changes in their code. They don't know what's wrong, they don't know what's right, they keep making random changes, and maybe something will eventually be right, and they say, okay, we're set. That's really a bad idea, increasingly self-defeating, because you're never likely to learn where the real problem lies. You may get something that works in the end, but you don't understand it. What you really want to do in the first place is understand the initial error you made. And a good way to do that often is by playing computer. So let's do a little more playing computer, this time on a piece of code that is wrong. Okay. It's entered in the examples here in number entries wrong. So let's look at it. I've got a playing computer table set up in this code. It's similar to what we had before, a little different. We've got item is a variable that's changing, and number. And so I've got the lines numbered. Let's start off. Let's suppose that we do this with a call to apple, pears, and bananas as the list. In that case, or the items, which are, it refers to the list. So when we start, the items is set to be this list. And then we go on to line 3. The first time we set item to be the first element, so it's apples. And then we go on to line 4, going the loop in order, and that sets number to be 1, which is where we want to start. And then we print the number in the item, and so that's currently 1 in apples. Go on and increment numbers. 2 is 1 plus 1. And then we go, because that's the bottom of the loop, back to line 3, set item to be the next element of the loop, pairs. On to line 4, numbers is 1. Then we print the number and the item. And at least by this point, when we're printing 1 pairs, you should see, oops, there's a problem. And if you've been following this through step by step, you should see that it was just in the line before that I set number back to 1. And that's not what I want. So this line isn't working right. And then you should be able to see, oh, I only want to initialize that once. That should be before the loop. And then you can not only fix the problem, but understand the problem. Let's continue playing computer back in the tutorial with the next example. This one corresponds to a mathematical situation where we had to find a function m of x here is equal to 5x. And if we let y equal 3, then finding this sum with function calls. The Python is written here. M of x returns 5x. Then the code to execute is y equals 3 and print this result. Let's look at this in detail, following back and forth with the parameters being passed and everything here. So I've got a playing computer table set up here. I've numbered the lines. We've got 2 variables, x and y, used in different places. And the first part is a definition, so the first executable line is line 4, where we set y to 3, as we have here. Then we go on to line 5, and we start working on this statement to print, but we come to a function call. So the first thing we want to do is calculate this. So we go back to line 1, and notice that since y was 3, we are passing 3 into the function. So then the formal parameter here, at the beginning of the function, becomes 3. Then we go on to the second line, and we return 5 times x, or 5 times 3, which is 15, returned in the second line. Now we got to remember where we were coming from, and it was in the middle of line 5. We were calculating this, so essentially we replace this m of y by the result 15, which means this line now is reducing to printing a 15 plus this other function call. So we need to do this other function call. First, we've got to calculate the expression here. Since y is 3, that means we're dealing with 2 times 3 minus 1, or 5. And so we're actually calling the function m on the parameter 5. And again, since it's function m, we go back to line 1 here. And now we're passing 5 to x. So we have here 5 for x. And we go on and calculate in line 2, 5, then times 5, and return it. And again, we're coming back into the middle of line 5. We've now replaced this essentially by its value. So we're left, given the previous value returned, to printing 15 plus 25. And then, of course, we can calculate 40 and print it. When you've written code of your own and you want to understand it, you have an advantage of sorts in that you know what you intended. But on the other hand, when you do make a mistake, you can be blind to it because you're thinking of the intention, not what you actually did. In playing computer, if you can totally concentrate on one line at a time, what you actually wrote, then you can follow through and find errors. And also, you can follow code that was written by somebody else that wasn't too well explained, or, as has happened to me, follow code that I wrote a while back and I didn't document and have forgotten what I did. Note that a couple of play computer exercises follow here.